Hello and welcome to my video, lesson 8.0, Unit Circle and Radians, but this is going to be the part B video, so if you haven't watched part A, which is how we got to this point, I highly recommend that you do so. This video we're going to be talking about the radians part. We understand the unit circle hopefully now, based off of everything we talked about in the drawing that we have on the screen right now. But what about radians? Well, radians are amazing. Radians are something that we've probably seen in our calculator. We always go away from radians. We always use degree mode, right? But radians are fantastic because radians allow us to solve things without our calculator much more easily because there's a pattern to it. Okay, so let's just take an aside here and talk about radians for a moment. Okay, so if we have a circle, okay, and we want to know the circumference of that circle, that's like the perimeter or the distance around the outside, we have a formula for it. In fact, this is the definition of what pi means. It's pi d, although most of us probably know it as 2 pi r. This is what pi was defined as. It's the ratio between the circumference and the diameter of a circle. That's the definition of pi and where pi has been defined as. So pretty cool. So this is the definition of pi. Very awesome. What does it mean for us now? Well, with radians and with our unit circle, we know that the radius is 1. Well, if the radius is 1, what is the circumference? Well, 2 pi times 1 for r. Well, that means the circumference of our unit circle is 2 pi. What does that mean? Well, that means our radian measurement for the full circle is 2 pi. This is key because this will allow us to do a lot of things. So that means over here, this is 0 radians and also 2 pi radians. Okay, so if that 360 position is 2 pi radians, what is my 180 position? Well, it's half of that, so it's just pi. We can split that in half again, and we get the value for 90 as pi over 2. And so at this point, you can see that if we go from 0 to 90, it's half a pi, and then from 90 to 180, it's another half a pi. So these are literally pi slices going from 0 to 1 full pi. And if we continue this sort of idea and we look at the 45 degrees spot, it's going to be pi over 4. Because again, this is half of the 90 degree position, pi over 2, and then you divide by 4 to get there. Or divide by 2 to get to pi over 4. And if you can see that, it goes to get from 0 to 45, it's a quarter of a pi. And then from 45 to 90, it's another quarter. If you have 2 quarters, it's like 1/2. Okay, what about the 30 degree position? The 30 degree position is a third of 90, right? 90 divided by 3 is 30. So what if we take pi over 2 and divide it by 3? What do we get? We get pi over 6. Okay, so if that's pi over 6, if we were to add it to itself 3 times, we get to 1/2. But what if we add it to itself only once? Well, that's how we get to the 60 degree position. From 30 to 60 is just 30 plus 30. So pi over 6 plus pi over 6, or doubled it, and we get pi over 3. So this is the radian measurement of those degrees there. So 30 degrees is pi over 6 radians. 45 degrees is pi over 4 radians. 60 degrees is pi over 3 radians. And this is important and allows us to eventually hopefully see a pattern here. If we continue this, if we look at the green one, it becomes kind of easy to look at. To go from 0 to 60 is pi over 3. To go from 60 to 1 20 is an extra pi over 3, right? So to this position, it's 2 pi over 3. To get to our next position, the 45, the 135, it'll be 45 plus 45 plus 45. There's 3 45s to get from 0 to 135. Well, 3 45s mean 3 pi over 4. And the red one is maybe a little bit harder to tell, but it's going to be 7 pi over 6. It's easier if you think of it being, 5 pi over 6. It's easier if you think of it as pi minus 1/6. Kind of like the reference angle idea, right? So 5 pi over 6. So 1 extra pi would get it to a full pi. Okay, so what do we notice just going from quadrant 1 to quadrant 2? Well, hopefully you notice that it's always pi over something, and then every 30-degree reference angle is always over 6. Every 45-degree reference angle is always over 4, and every 60-degree reference angle is always over 3. This allows us to continue the pattern going around much more easily. So this is going to be over 6, and it's 1 extra pi. This is going to be over 6 as well, but it's going to be 1 less than 12, so it's going to be 11 pi. The blue ones are going to be over 4, so something pi over 4, and this is 1 extra, so it's going to be 5 pi over 4, and then this is going to be 1 less than 8, so it's going to be 7 pi over 4. And this one's going to be over 3, because it's in the 60-degree position, so it's something pi over 3. But this one is 1 extra, so it's 4 pi over 3. This is 1 less than 6, so it's 5 pi over 3. So now we've filled in this entire unit circle, but with radians. And this is very important. This is very wonderful, because now every time you see a radian measurement that says over 3, you can already immediately tell what sign is going to be. Because every time radians are over 3, sign is always the same, root 3 over 2. The question is it positive or negative? But it's always root 3 over 2. And cos is always, always, always 1/2 if it's 60, if it's a 60-degree reference angle. But instead of thinking 60, you can just look at the denominator. Is the denominator 3? Yes? Well then, cos must be a 1/2. And then you can just, again, ask the question, is it positive or negative? So this can speed things up quite a bit, and that's why we like radians. Radians are just another way of measuring an angle. It's just another measurement. It's like talking about centimeters and meters, or centimeters and inches, kilometers, miles, pounds and kilograms. It's just another measurement. But it's a measurement that's based off the circumference of a circle. The circumference that we already defined as 2 pi r. But the radius, again, is 1 because it's the unit circle. And this is awesome. This is very awesome, because this means when we're looking for the arc length, it becomes much easier. When we're looking for a value, we can get the exact value much more easily. So I hope this video helped you better understand the basics here. One last thing to mention before we pack it up here is that radians are defined as pi equals 180 degrees. So if we're just converting between radians and degrees, just be aware that this is the unit conversion, and it's just coming from right here. Or you can think 2 pi equals 360. That's honestly how my brain works because of this circumference concept. So I hope this video helped you better understand the unit circle and radians, and I hope that this makes a lot of sense. Good luck.